traditional construction, prefab takes place indoors where the climate is controlled, making the work super fast and hyper efficient. The finished building blocks are then assembled rapidly on location. It's like putting together a mega Lego set on steroids.
的过程就是一系列的把它分割开，然后重组起来。
Convinced he's found the perfect method, Dr. Yin builds Taiwan's largest and most advanced prefab plant. 10 soccer fields in size. So efficient, it can churn out 100,000 cubic meters of concrete blocks in a single year.
那任何人盖的话，需要1整年的时间，但我们只花了108天。
The plant's biggest challenge? To customize their prefab process for buildings of totally different shapes and sizes. A $1 billion high-tech factory, a 22,000-seat stadium, and a towering 38-story luxury residential block. Tough deadlines, the unforgiving Taiwanese terrain, and the threat of typhoons will take engineers to breaking point. Will success seal their reputation as Taiwan's genius?
这边的网络这么慢吗？这部有45分钟长，想看不完了。
The giant work floor, 10 soccer fields in area, manufactures concrete blocks for mega buildings, ultra fast and ultra strong. Unlike conventional structures, these prefab buildings can also withstand the most violent earthquakes.
模式建筑，第一个呢，品质呢比传统的高很多；第二呢，时间呢往往用不到一半，效率很高。
The secret to this factory lies in its finely tuned 4-stage process. The steel shop, where high-grade steel is cut and bent into shape. The assembly line, where the steel skeletons of prefab building blocks are put together. And a concrete casting and molding facility, where the mega building blocks get their final shape, ready for delivery.
王振仲，我们今天很高兴。
Operational efficiency is crucial, but it's the ingenious machines that give production an edge. Giant spring manufacturing equipment churns out unique steel spirals that form the skeleton of columns and beams. It's an eco-friendly process that reduces the demand for raw steel by 30%.
这个地方是我们生产的起点，也就是说我们的钢筋加工生产的机密。那我们是用机械呢来代替人工，对这个产量的提升有很大的帮助。
The factory is geared up for the challenge ahead. Time now to turn theory into practice. Are they up to the task? To prefab 3 massive buildings of different sizes and shapes in record time. The Taipei Stadium, the 38-story Ocean Blue condominium, and the largest of all, the 600,000 square meter Innolux plant. Innolux is a homegrown liquid crystal display manufacturer in Taiwan's rapidly growing IT industry. The billion-dollar business is one of Taiwan's most important exports. For companies like Innolux to stay competitive, they require high-tech factories to assemble their sophisticated products. The faster they get their factory built, the earlier they can generate income.
60层这个状况，就是说，因为这60层事实上这个上面的基础是稳定。
Innolux's latest factory is their most ambitious to date. In 12 months, engineers have to complete the building and also make it earthquake-proof to protect the factory's sophisticated equipment.
但是绝对不可能。
It's a punishing set of challenges that no standard building methods can meet. Except for prefabrication.
Here we have the rebar cage.
Engineer Mo is in charge of constructing a building that's up to the job.
In the conventional way, if we want to build such a big project, we usually take 2.5 years. Now we only take 1 year.
Work starts on the plant's massive foundation. Engineers excavate a gigantic area measuring 100,000 square meters. Thousands of tons of steel piles are welded together to form the building's 6-story framework. But these are the easy parts. The biggest challenge is to tailor-make the floors of the plant's largest cleanroom facility. Cleanrooms are the most important part of the factory. They prevent environmental pollutants like dust or microbes from ruining the microchips that Innolux manufactures. Inside, a filtering system controls air contamination levels through multiple ventilation points built into the floor. This means that cleanroom floors are riddled with large holes. So how do you construct a giant floor filled with hundreds of holes while making it earthquake-proof? The engineer's plan is to split the cleanroom's 48,000 square meters of flooring into 1,800 smaller sections, making them easier to prefabricate. Then, to strengthen each piece, they will double the amount of steel and concrete. At the same time, a massive net of steel will form the frame of the floor, holding the pieces together. In this way, the customized floor is strong and stable enough to withstand the most violent quakes. With the perfect plan in place, the prefab factory now needs to build the perfect floor. First, a crack force of craftsmen binds the steel skeleton of each floor slab together. The work is fast-paced and done entirely by hand.
And then we have using this skeleton put inside of the mold. Here is the mold. Here you can see because they have all these grooves and then all the skeleton of this our concrete slab. They will be fixed into the right location. After the skeleton inside, and we put the bucket inside here, and then we cast the concrete.
As the concrete is poured into the mold, the plastic buckets help to form the shape of the vital ventilation holes. With just 22 molds, the factory is able to prefab all 1,800 floor pieces in less than 3 months.
And because we we have to insert all these tubes to get the ventilation. It looks like the cheese, so that we call cheese slab.
The last stage of the process is to install each of the 25-ton floor slabs. Not on the ground floor, but 4 stories up. For engineers, it's the most dangerous part of the construction.
The most dangerous things is you can see for this 25 tons slab, we have to lift it up to about 30 meter height and insert it to about 10 meter narrow gap.
For a job like this, you need a heavy lifter. A 120-ton crane capable of hoisting these giant blocks into place. A crew at the top slides and drops the massive sections into the steel framework.
You can see, now it's up to the right floor, and we get that one into that one. The most dangerous part is inserting the slab. If it doesn't make properly, then we have a big problem. This is a big disaster.
After a harrowing half an hour, and with only inches to spare, the slab rests safely at the top and is moved into position. Over 10 months, engineers installed thousands more floor slabs and put the finishing touches to the factory. Completion of the project is at last a success.
This is an exciting experience for me because we have to finish this big project in such a short time. The precast helped us to accomplish this mission.
With the Innolux plant completed, engineers turn their attention to another mega project, the $70 million Taipei Stadium. It usually takes over 30 months to build a stadium this size. But engineers are going to use prefab to shave more than 5 months off the schedule. If they succeed, it will be the fastest stadium ever built in Taiwan. Only one problem. The city of Taipei sits on some of the softest soil on the island. A condition made worse by an extremely high water table that rises during the annual typhoon season. If engineers want to get the stadium ready in time, they will have to prevent it from sinking into the ground. Homegrown innovation has been the powerhouse that's propelled Taiwan into the future. The island's largest prefabrication factory is attempting its most ambitious projects to date. Constructing 3 mega buildings in record times. Engineers took just 1 year to complete the massive 600,000 square meter Innolux plant. Now they turn their attention to their next 2 missions. The 38-story Ocean Blue condominium and the 22,000-seat Taipei Stadium. Commissioned specially for the 2009 Deaf Olympics, the stadium has to be ready in less than 25 months. It usually takes more than than 30 months to complete something this big. If engineers succeed, they will make construction history. Engineer Zhang leads the project.
为了这个场馆的新建啊，为了要达到如期的完工，所以我们啊，在设计方面呢，在施工上我们采用了传统的工法，加上钢构的工法，以及搭配大部分的预鑄工程。
Back at the prefab factory, engineers customize the stadium's 900 seating slabs. Specially designed molds of different sizes and shapes churn out the 15-centimeter thick parts. This way, 16 seating slabs can be completed in a single day. A feat conventional methods will find hard to beat.
预鑄可以解决非常多的问题，它可以克服各种形状的板片，可以做弧形板或是直线板。
More than 40 steel trusses are also prefabricated to form the stadium's roof, each weighing 35 tons. Everything is ready to be assembled. But first, engineers have to overcome a sticky problem that could ruin their foundation. Soft clay. This unstable soil underlies Taipei because the city sits on a basin. And as the basin is intersected by 4 rivers, the soil also suffers from a high water table, just 2 meters beneath the surface.
要达到如期完工的过程啊，最重要的一点就是要克服台北市的一个地质的问题。
Complicating the problem even further is the threat posed by the engineer's deadliest foe: earthquakes.
Because the city of Taipei has a thick layer of soft soil. When earthquake comes, the earthquake wave will pass through this thick layer of soft soil, and some of the earthquake waves will be amplified. Therefore, the building built on this layer of soil could suffer serious vibrations.
For engineers to complete the stadium in time, they need a solution that will both stabilize their soft foundation and counter the threat of an earthquake.
那需要什么帮助的话？
Prefabrication can't help engineers in this situation. They need to come up with an alternative solution. One option is to drill steel foundation piles deep into the earth. But it's a time-consuming process, and the amount of steel needed makes it an expensive scheme. What's worse, an earthquake or a hidden pocket of clay could destabilize the steel piles, causing part of the stadium to collapse. Engineers turn to a conventional but highly effective technique to tackle both problems: mat foundations. Engineers will excavate close to 5 meters down until they hit sand, a stronger and heavier material than clay. Then they'll place a bed of steel onto the sand, reinforced with concrete, creating a mat foundation. By building countless mat foundations around the 600-meter circumference of the stadium, the weight of the structure is distributed evenly across and under the site, allowing it to sit undisturbed within the soft clay and high water table. Even if an earthquake hits, the stadium will move as one in the soft soil, just like a ship floating at sea.
我们的结构部的结构计算呢，为了解决这个整个因为环状基础的开挖，经过了所有的检讨，认为说这个华氏基础啊， 是一个最优良的一个基础结构方式。
Work begins. First, engineers construct a series of waterproof steel structures called cofferdams. These temporary structures surround the worksite with a wall of steel sheet piles, making it safe to work inside. Then they assemble the steel skeleton of the mat foundation. Workers pour tons upon tons of fast-setting concrete to give the foundation its final shape. But before engineers can finish their work, disaster strikes. The annual typhoon season hits Taipei. A Category 2 typhoon makes landfall east of the city, causing flash floods and landslides, clocking wind speeds of more than 180 kilometers per hour. At the stadium, almost all the cofferdams are inundated with rain. It's a major setback for the crew.
我们就发现到这个淹水的深度啊，达到差不多有1公尺半左右啊，差不多一个人的深度了。心理上就觉得非常的惶恐，也非常的无奈。但是呢，我们还是要准备很多的应变措施啊，比如说如何来防治台风的损害。
Engineers work non-stop to come up with the most efficient salvage plan. They use every pump at their disposal to discharge the water from the cofferdams.
那我们呢，马上就准备了大概有10台的5匹马力的的抽水机啊，运用外接的发电机来抽水，足足嘛抽了大概有3天的时间，为了不影响后续的工作。
Engineers overcome the potential disaster. Now they begin to assemble the rest of the structure at breakneck speed. The stadium's 900 seating slabs go into position in just 2 months. 3 men and a crane are all it takes to get the job done. And after bolting its massive roof trusses into place, Taipei Stadium begins to take its final shape. Engineers have successfully met their tight deadline.
能够把这个体育场啊，在工期之内，在品质的管控之内啊，如期的完成，感到非常的高兴。如果说今天这个场馆呢，用传统的工法来兴建它的话，起码比我们这个预铸的工法最少要多1年。
With the stadium complete, the prefab factory begins work on another giant project. A towering luxury condominium called Ocean Blue. At 38 stories, Ocean Blue will be the tallest prefab building in Taiwan, constructed in less than 2 years.
好，后面还有15分钟哦。那个有兴趣的同学自己的从上面的官网上面去那个网址上面去点选，自己去看就好了。那到目前为止有没有什么其他问题？好。好，如果没有问题的话，那今天就上课到这边哈，谢谢。